Let's see what we can do about solving this system of three equations with three variables. So our process is to choose two equations, two pairs of equations. So why don't we choose 1 and 2 and 1 and 3, and we'll eliminate one of the variables, and it doesn't matter, we can choose x, y, or z. Why don't we just eliminate x and see what happens? So to eliminate, let's start here with 1 and 2, and what we're going to do here is eliminate x, and that will leave us getting y and z. So we know how to do this. We're going to look at these coefficients of x and make them opposites. So the smallest number of this 1 and 3 will go into is 3. So why don't we do this? Let's multiply equation 1 by -3 to get that opposite, and then add equation 2 since it's already a 3. That'll look like this. So let's pass a 3 through this first equation. Multiply everything in here by -3. So that'll give us -3x minus 6y plus 9z equals positive 33. And then equation 2 is 3x minus y plus 2z equals 3. And when we add these together, sure enough, the x's are gone. We'll get -7y plus 10z equals 36. So here's another equation for us. Why don't we call this one equation 4. All right, so now what we'll do is we'll use equations 1 and 3 and eliminate x. So let's give this a try. So let's look at 1 and 3. So we've got 1 and 3. The smallest number of these coefficients divide into is 2, so let's make them opposites. We'll multiply the top equation by -2. That'll look like this. -2 times equation 1 plus equation 3. So let's run a -2 through this first equation. That'll look like this. -2x minus 4y plus 6z is equal to positive 22. And equation 3 is 2x plus 4y minus 6z is equal to -2. And when we add these together, the x's are gone, the y's are gone, and the z's are gone. So we'll end up with 0 equals 20, which is false. And as in the case of 2x2s, when we eliminate all the variables and get a false statement, this means at least two of these planes are parallel, and there is no solution to this system. So to eliminate x from 1 and 3, let's focus in on these coefficients up here. This is a 1, this is a 2. The smallest number they divide into is 2. We need them to be opposite. So how about this? Let's run a -2 through equation 1 and then add that to equation 3. So let's pass a -2 through this top equation, multiply all the coefficients there and constant by -2, and that will give us -2x minus 4y plus 6z is equal to positive 22. And then equation 3 is 2x plus 4y minus 6z is equal to -2. And if we add these together, the x's are gone. -2x and 2x is 0. The y's are gone. -4y plus 4y is 0. And the z's are gone. 6z minus 6z is 0. So what we end up here with is 0 is equal to 20, which we know is false. And just as the case of 2x2s, when we eliminate all the variables and get a false statement, we know that at least, in this case, at least two planes are parallel. And that gives us no solution. So this system has no solution. You know, we might be able to see this. Let's take a look at this. Look at equation 1. Look at these coefficients in equation 1 and equation 3 and compare them. Here's a 1. This is a 2, doubled. Here's a 2. This is a 4, doubled. Here's a -3. Here's a -6, doubled. And on the right side, though, here's a -11, and this is not doubled. So what we've got is double, 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 not double. So that indicates parallel lines, or in this case, parallel planes. And right away, if we recognize that, then we know that there's no solution.